In this video, we'll use factorial and double factorial to generate the Taylor-Maclaurin series sum of inverse hyperbolic sine. We begin with the dataset of the inverse hyperbolic sine, which is equal to array formula a sine hx of the x value. And we'll chart this. Insert chart. We will use scatter chart. Use row 1 as header. Show the trend line. That's trend line. Polynomial to the 8th degree. The label, we use the equation, and the legend, position at the bottom. Radial axis, show the axis line, and the number format, none. In the horizontal axis, the number format is also none. So here's the trend line and trend line polynomial of the inverse hyperbolic sine. Next, we generate the same using Taylor-Maclaurin series sum, where it is the summation of a times x to the power 2n plus 1, where a comes in the form of a1, which is negative 1 to the power factorial 2n, all over 4 to the power n, times factorial n squared times the quantity 2n plus 1. The other coefficient is factorial double, so double factorial of 2n minus 1 divided by negative 2 to the power n times factorial of n times the quantity 2n plus 1. And the value of n starts from 0 to infinity. We can go as far as 16. Next, we generate the coefficient, starting with the double factorial, which is array formula. That's factorial double of 2 times n. This is our n plus 1. Divided by, you have the denominator. Denominator has 3 parts. So we'll just copy the value of n, f3 to f19. So the first part, it is negative 2 raised to the power n. That's negative 2 raised to the power n. Second part, times factorial of n. And finally, the third part, the quantity 2n plus 1. 2 times n plus 1. And enter. I think there's something wrong. This is 2n minus 1. That's not 2n, it's 2n minus 1. So, there's an error. So our calculations are good. Now we correct this. So if that is, if n equals 0, then 1, otherwise calculate. So we're good. Our calculations, our formulas are matched, and we'll complete the Taylor-Maclaurin series sum. So array formula, series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from at n equals 0, 1. So 1. The increment. So 2n plus 1, 3. 2n times 2, 5 plus 1, 5. 2 times 3 plus 1, 7. So 1, 3, 5, 7, 9, 11. So the increment is 2. And the coefficient, it will be this range. And we show the equation. So edit chart, trend line, polynomial to the 8th degree. Use the equation as label. And we'll calculate these regression coefficients using Linus. To do that, we complete the Linus matrix starting with the power. So transpose 0 to 8. And the elements are a formula of the x values raised to the power 0 to 8. Now we can use Linus. Linus data y and data x. That's for the inverse hyperbolic sine. It's Taylor-Maclaurin series sum expansion. Linus, because this has expansion, and data x. So their polynomial regression coefficients are the same. X to the 0, 0. X, it's 1. X squared is 0. That's 0. X cubed is negative 0.166. And x to the 4th, 0. X to the 5th, 0.0681. X to the 6th, 0. X to the 7th, minus 0.0224. And x to the 8th, 0. Now we'll use the factorial. We've done with the factorial double. We use the factorial. So array formula, minus 1 to the power n. So n times factorial of n. That's the numerator. Now we continue with the denominator. There are three parts. The first part, 4 to the power n. So 4 to the power n times factorial n squared. So factorial n, this is n, and square it, times the quantity 2n plus 1. So quantity 2 times n plus 1. Then enter. Are we missing something? So negative 1 factorial of 2n. So this is 2n, not n. This is 2 times n. 2 times n. Now we're good. The numbers are exactly the same. Let's say I will use this factorial in the expansion. So I'll correct this. Instead of this, I'll use the D column. So D and D. So this column. Then enter. Still get the same values. The polynomial regression coefficients are the same, and the data sets are still the same. Suppose I use the E column. So E E3, and E19. This column. Enter. Now this is the result of the double factorial. They're the same. If I use the factorial, I use the D column. D, and this is D19, D3 and D19. And the result will be, this is the factorial column, factorial, and the data sets are still the same. This completes the use of factorial and double factorial in generating the Taylor-Maclaurin series sum expansion of inverse hyperbolic sine.